This is your Pacific Ocean, and you know that Pacific Ocean is the single ocean where almost all parts are active. Means on the eastern and western, both parts, you can see trenches. Means here is also subduction happening, and here also subduction is happening. On both parts of the ocean, subduction is happening. Means both parts of the oceans are having active plate boundaries. There are two terms: active plate boundaries and passive plate boundaries. In active plate boundaries, you can see trenches. Okay. In active plate boundaries, you can see trenches because there subduction is happening. One plate is going underneath another plate. Okay. So a term may be used in your question that Pacific plate has more active plate boundaries. So it is a right statement because it has trenches all over there. You should start from here. Here, trenches are more important than the mid-oceanic ridge system, because here the mid-oceanic ridge system is not found in the middle part, but in the somewhat eastern part. Like this, here it is called East Pacific Rise. Here, ridge is not in the form of a wall; it is form of a slope. That is why they are called East Pacific Rise, because they are found on the eastern part of the Pacific. Here, the mid-oceanic ridge system is over here. Just this means all the sea floor is spreading from here only. Understood? And this whole plate. And here, this whole plate is subducting alongside these trench areas. And on other part of the trenches also, here is, means the movement is like this. As we have discussed, these Japan, these Philippines and Indonesian islands are the result of oceanic collision. Means two types of oceanic plates are colliding with each other, and the oceanic plate which is heavier, means it might be that because these they both are the oceanic plates, but this plate may be heavier or this plate may be heavier. So here you can see that this plate is, if this plate is heavier, this will go underneath this plate and it will melt down here, and magma will come out in this manner, and here volcanoes would be formed. And if these volcanoes come out of the oceanic waters, they will look like islands, though they are volcanic islands. They are known as also volcanic arcs, like Japan, like Philippines, Indonesia, right? So here you can see that here are trenches. Trenches are made in this manner. Like this part of the Pacific plate, on both parts of these trenches or islands, here is also oceanic plate, here is also oceanic plate. Means this plate is actually, this plate is like this continuous plate. Okay. Its marginal parts are oceanic, but its larger part are continental. This Eurasian plate, but its marginal parts are oceanic. Okay. So here, this heavier plate will go underneath, and such type of trenches are found alongside boundaries. Okay, here also and here also. This is the Peru-Chile or Atacama Trench. This is the longest trench of any ocean. 𝗂𝐴𝐵 or Atacama Trench. Longest trench. And here in this trench, Mariana Trench, this is the deepest trench of any ocean. Mariana Trench. Okay. So please focus on these things, like this Aleutian Trench starting from here, from northern part. Means here near the Bering Sea. Yeah, there is one more feature that in all parts, in all these trenches, you can see back arc basins or back arc seas. Means here you can find this Bering Sea. Here there is a Okhotsk Sea. This sea is Okhotsk Sea. This sea is called Japan Sea. This sea is called South China Basin or South China Sea. Okay, in all these, they are called back arc basins or back arc seas. In all these trench areas, you will find the back arc. The term is like this: back arc basins or seas. These basins are known with a particular name. These back arc basins, and this is a special feature of Pacific Ocean. In no other oceanic areas such back arc basins are found, because here is a particular mechanism, a particular condition, because on both parts of the trenches there is oceanic area. Okay, because here two types of oceanic plates are converging, they are colliding. So you will find back arc basins on the other side of all these islands or all these trenches, you can say. Means the pattern is like this: if you are coming from this oceanic area, you will first find the trench, then you will find the volcanic arc, then you will find the back arc basin. Means the sequence is like this. UPSC asks questions based on sequences. A very beautiful question can be asked, that what is the sequence? Okay, first you will encounter the trench area, then volcanic arc area, then back arc basin or seas.
If ocean doesn't break convergence and subduction, then volcanic islands are always there.
Yeah, like this. Okay, because one part of the plate would it would subduct and melt over here, and the molten material will come out in the form of volcano. Okay, so this is the sequence. Yeah. No, they are just like basins, seas. Means this is Japan Trench. Okay, like this is Japan Trench. Then this is Japan Island. Then behind this part happens to be like a basin or sea. This is technically called back arc basin. Means on the back part of the arc, volcanic arc. Okay, they are just like seas or basins. Understood? So this is the sequence here. Okay. So all these trenches are important. Starting from here, Aleutian Trench, and its back arc basin is Bering Sea. Okay. On the back of it, there is Bering Sea. This is Kuril Trench. On back of it, this is Okhotsk Sea. This sea is known as Okhotsk Sea. The problem is that we see the Atlas classes and these classes in a different manner, but they are integrated. They should be integrated. Means while studying these things, you should also open your Atlas and see them over there. Right now? After completing these classes, I would be doing those Atlas classes also. But up to then, who knows that you will forget all these things that we have studied. Back arc basins over there. There you will see those things only just names, that this is Bering Sea. Actually, this sea is formed in a particular manner. Okay. Before the formation of these volcanic arcs, there was no sea. There was no sea. For a sea formation, means a sea, though it is a part of the ocean, but it should be sheltered in a manner, in a somewhat sheltered position. Okay, so that is why, because here is an island, volcanic island, this is in a sheltered position. That is why we know it by a different name. Okay, Bering Sea, Okhotsk Sea, here is Japan Sea, here is South China Sea. This is South China Basin or South China Sea. Okay, so these trenches and these seas both are important. Bonin, yeah, this is Aleutian Trench, then this is Kuril Trench, then Japan Trench, then this is Bonin Trench. This is Japan Sea. This is Yellow Sea. Actually, this is Yellow Sea. This particular sea is Yellow Sea. Behind this Bonin Trench, this particular sea is, this is also known as North China Sea. This whole part is also known as North China Sea, and this particular sea is known as Yellow Sea, where the Huanghe River has its mouth. Huanghe River. Huanghe, the Yellow River. Here Huanghe River comes and it flows like this. Huanghe. Okay, this is also called Yellow River, and that is why it is called Yellow Sea, because Huanghe carries with it a large amount of loess. Loess is a special type of soil there. Okay, and for loess formation, not only river is needed, along with river there are some wind movements are also needed. So this is a wind and river blown deposit, loess. Okay, and it is of yellow color. That is why it is known as Yellow River. Loess deposits. Okay, and the area where from this river flows is known as Loess Plateau, and it erodes away the material, the soil, and that deposit is known as loess, and it deposits all this loess over here, and the all part of this sea becomes yellow. That is why known as Yellow Sea. Okay, then this Mindanao Trench alongside Philippines. This is the Mindanao island of Philippines. A part of the Philippines is known as Mindanao Island. By its name, it is called Mindanao Trench. And here there is Mariana Trench. Then this large sea is known as Coral Sea. This large sea is known as Coral Sea. Here more or less coral islands are found. That is why it is known as Coral Sea. We will also study coral reefs, okay, in oceanography. So it is Coral Sea. And on the southern part, this is Tasman Sea or Tasman Basin. Nearby Tasmania, you know Tasmania? On the southern tip of Australia, this small island is known as Tasmania. A small island. This island is known as Tasmania, and by its name, it is known as Tasman Basin. Means the series of trenches is continuous. Means this is also a trench, Tonga Trench, and this is the back arc basin. This is Tonga Trench, and this is the back arc basin of Tonga Trench. Like here. Means all these seas are like a back arc basin. Okay. This is Kermadec Trench. Here, this is New Zealand Islands. You just forget the names of volcanoes. Here was a very important volcano. In New Zealand, here was Mount Egmont. Recalled it? You just go to your home and sleep there. No revision. Mount Egmont. Okay. So, Tasman Sea. Yeah. So this is Coral Sea, this is Tasman Sea. Okay. Yeah, important. It is important volcano in New Zealand, Mount Egmont. So this is the western part of the Pacific Ocean. Now come to eastern part. In the middle, there is Hawaiian Ridge. Okay, all Hawaiian Islands are part of this ridge system, the smaller ridge system. And you know that this is the intraplate boundary. Intraplate volcanism is over here. Means it is middle of the Pacific plate. Okay, intraplate means middle in the middle of the a particular plate. So these Hawaiian volcanoes are located here in the middle part of the Pacific plate. Then here, this ridge system is like this. Okay, a branch is known as Chile Rise. Its middle part is known as the East Pacific Plateau. This ridge is known as the East Pacific Ridge System. Like that was Mid-Atlantic Ridge. This is known as the East Pacific Ridge because it is found on the eastern side of the Pacific Ocean. East Pacific Ridge. Okay. And the central part of this East Pacific Ridge is known as the Southeast Pacific Plateau or simply East Pacific Plateau. It looks like a plateau. Okay. Its northern part is known as the Albatross Plateau. Also important plateau, Albatross Plateau. Then there is a small branch of this ridge system known as the Chile Rise because it is alongside Chile. And this is the trench system known as the Peru-Chile Trench or Atacama Trench because here is a desert known as Atacama. Here is Atacama Desert. So because of that desert, it is also known as Atacama Trench. Yeah, it is a cold desert because its location is on the higher latitudes. Okay, hot deserts are in tropical zone. If a desert is in temperate zone, it will be a cold desert. Because here you can see that this is the temperate zone. Okay, that is why it is a cold desert. Aridity features are there, but caused by cold climate, not by hot climate. How the deserts of mid latitudes, like Thar Desert, like Kalahari, like Sahara, how these deserts came into being? Don't know. Yeah, means how a particular desert like Sahara, like Kalahari Desert, okay, all the mid latitude deserts. Why rains are not occurring on those desert areas? Mountains actually help in rains. Actually, all these deserts, which are called hot deserts or mid latitude deserts, they are located on particular zones where they are located just below the subtropical high pressure belts. Okay, so what is the feature of high pressure belts? From high pressure belts, winds are always descending. When you will study in climatology the air circulation, okay, you will understand that your equatorial areas, okay, they are low pressure belts. All the equatorial areas are low pressure belts. Why are they low pressure belts? Why are they low pressure belts? Why how low pressure is being accentuated there? You should directly say, means yeah, such type of conversation helps in interview. Means if I am asking how low pressure is being made, you should just answer that because air is rising. If in any manner air rises, it will make low pressure over here. Okay, air may rise because of obstruction of a mountain over here. It may also rise because of the heating. Okay, because in the 0-degree equator areas, sun is always there. Air is heated. Air is heated in a manner and it goes upwards. When it goes upwards, when it rises, it will make low pressure over there. Okay. Then what is the mechanism of high pressure? Just opposite of that. If in a particular zone, air would be descending. If air is sinking, okay, how will it sink? In opposite way. When it will become colder, it will sink down. And while sinking down, it will make high pressure here. Like you are standing here, air is coming over your head, you will feel high pressure. Understood? So your answer should be direct. When I am saying that how low pressure is being created, air is rising. Just okay. How high pressure is being created, air is sinking, air is subsiding. Okay, so in those areas where those mid-latitude deserts are located, actually air is always sinking because that is the area where there is subtropical high pressure belt. Air always sink down. And for any type of precipitation, the first condition is air should be rising. Whether with the help of a mountain back that you call orographic rainfall, or by the heating of the air that you call advectional or convectional rainfall. Somebody is asking something. Due to solar irradiance which cause increase in temperature, which in turn lighten up the air particles and air rise happens. Yes, good. Which creates low pressure and then yes, good Hempuja. She is a वो आराम से अपने घर पे थोड़ा सा आराम से भी है ना, यहाँ पे यू आर इन सिटिंग पोजीशन. पोस्ट लंच सिनेरियो. So this is the mechanism. Okay, how mid-latitude deserts are created. I think in 2013 or 14, this question was asked in mains. Very few people were able to answer this question. Onshore, offshore is also there. That feature is also there, but more. Yeah. When winds are offshore, means, but that particular mechanism attaches with those deserts only, which are on the leeward areas of the mountains. Like here is a mountain. Okay, wind is coming from here. This is the windward side of the mountain. So these winds will cause rainfall here. Okay, while rising on the mountain back, they will cause rainfall. Like in the western part of the Western Ghats, there is more rainfall on the western part of the Western Ghats because monsoon air are there windward. Okay, but on this part, while air would be descending on this mountain slope, while descending down, they will become colder and colder. When air rises, okay, warmer and warmer. When air will rise, it will get colder and colder. Okay, and in that process, condensation will happen and they will cause rainfall. But while it will come downwards on the leeward slope. This is the windward slope and this is the leeward slope. On the leeward slope, air would be descending down and they will become warmer and warmer. When air becomes warmer, its water holding or you can say moisture holding capacity increases. It will not release the water in the form of precipitation. Okay, while it gets colder, its water holding capacity reduces. And condensation is what? When its water holding capacity is reached. Okay, so it cannot hold the excess water. So that happens when air becomes colder and colder. Understood? When it descends down, it will become warmer and warmer. Means whatever amount of moisture, if a particular area, like in Thar desert, like in Sahara desert, if air has some moisture, even if it has some moisture, it will not precipitate. because air would be always descending down, and in that manner their water holding capacity will be increased. They can hold that amount of moisture because of that descending mechanism. If by any means air would be rising, they could cause some amount of water, okay, some amount of rainfall there. Understood? But there is no condition over there because they are located on that particular belt, high pressure belt. Air are always descending over there. Okay, the manner is like this. If some air for local regions tries to get some moisture and rise up, those descending air, they would push down that particular air also, those local airs. Okay, because they are more powerful. They are descending down a particular belt. If there are some local airs, they may have some moisture and they want to rise up. Those airs descending down, they will push up. They will hinder their rising activity. Understood? That is why those deserts are always deserts. So you have understood all these features. Okay. I am moving from oceanography to climatology now and again. But that is the beauty of this subject. You can move. Okay, you can integrate all the topics. So these are East Pacific ridge, Pacific Antarctic ridge, 𝗂𝗯𝗶𝗰𝗂𝐃𝐨𝐰𝐧𝐥𝐨𝐚𝐝 ridge. They are smaller ridges, not so important. Okay. Trenches, Mariana Trench, Tonga Trench, Japan Trench. All the trenches we have seen on those maps. Okay. Now this temperature and salinity patterns. There is not much to memorize in this part, but to understand. Okay, like to understand the oceanic circulation pattern, you need to know that how the temperature and salinity changes on the various parts of the oceans. What is the pattern? Means their horizontal pattern, their vertical pattern, how the temperature changes, how the salinity changes, because these are the two factors which decide the movement of oceanic currents. Oceanic currents are mainly caused by temperature and salinity changes. First, you should understand this thing. You should understand these factors, like factors affecting the distribution of temperature in the oceanic areas. First and foremost factor is latitude. As you know, that if any part of ocean is in higher latitudes, like in polar areas, like in first you should know that this is the Earth, this is 0 degree equator. Again, we are studying climatology. This is 30 degree, but this is important, 60 degree north. In prelims, questions are asked from this. Okay, this is your tropical zone. 0 to 10 degree, especially, it is known as equatorial. On both sides of the 0 degree equator, means from 10 degree north to 10 degree south, this part is known as equatorial zone. But up to 30 degree north to 30 degree south, it is known as tropical zone. This whole zone is tropical zone. Zone means the area between two latitudes. Then this is the temperate zone. Then this is polar zone. Okay, draw this figure. 0 to 10 degree north, equatorial zone. From 0 to 30 degree north, this whole zone means equatorial zone is part of this tropical zone. Then 30 degree north to 60 degree north, it is temperate zone. Then from 60 degree north to North Pole, it is polar zone. The same pattern here in the southern hemisphere. Subtropical zone. Actually, this transitional zone is also known as subtropical zone, between tropics and temperate. Subtropics or the transition zone between temperate and tropical. Means directly you will not go from tropical to temperate. After tropical, there will be a zone where temperature would be somewhat warmer. Yeah? Yeah, around 30 degrees east, you can say 30 degree north or 30 degrees south, around those areas, you'll find subtropical. That is why they are known as subtropical high pressure belt. This whole belt is known as subtropical high pressure belt, because the air which are rising from this equatorial areas, they are air are rising like this. Like this is the surface of the, like this is 0 degree. Okay, this is 0 degree. This is 30 degree north. Okay, this is 30 degree south. Like you are standing here. Here, because of the high sun, always there is high sun. Okay, so air would be hitting in this manner and rising and going up to the tropopause level. There is a level of atmosphere, this is known as tropopause. Then they would be diverging like this, and after being cooler and cooler, when air will be cooled, it will descend. Here air is being heated, it is rising. Okay, so in this manner, here it is making a low pressure. In and around 0 degree, it is making low pressure. Where? On the ground. On the ground. If you are standing here, you will feel low pressure. And if you are standing here, you are feeling high pressure here and here. Correct? So those deserts are located here, 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 and here, here, here. Okay. There is always a condition of subsiding air. So we'll discuss these things in the next class. Okay. Let us end here. Sir will be taking. Thank you all.
Introducing the Prelims Target course and Prelims Test Series at ProdEgyIAS. Designed for UPSC Prelims 2026, this comprehensive program offers in-depth classes on history, geography, science and tech, environment, polity and governance, and economy. Stay updated with current affairs and sharpen your skills with our Prelims Test Series consisting of 50 full-length tests covering all subjects along with CSAT. Join ProdEgyIAS and stay ahead.